James, Daniel, how's it going?
Good. How are you?
I'm doing pretty well. You, John, good to see you. Even though I just saw you, good to see you again. And for everyone else, yeah, we'll probably get started in about 5 minutes. We usually like to give people time to get in. I've always thought I should just have some good like wait music lined up and just.
Like some elevator type music just kind of going on in
Yeah.
the background.
Yeah,
Yeah.
exactly. So people come in, they're like, oh, okay, this thing's not started yet, but it's going to start. So I don't know what.
Oh, well, you have the guitar behind you. That might be.
Yeah. Oh, yeah. Should I
Yeah.
just play it?
Yeah. That's much better. Yeah.
Yeah. Yeah. Gives a little professional feel. We like to do things professionally around here. Good to see you all. We're gonna get started in probably about 2 or so minutes. There's a lot. Usually like to give people a few minutes as they often are coming from other meetings or whatnot. So give everyone a few more minutes before we actually kick it all off. While we are waiting, if you do want to drop in the chat where you're calling in from, that's always a good way to kick us off. So as of right now, I am in Sioux Falls, South Dakota. But I kind of wish I was where James and Daniel were at.
Yeah, we're out in Malta right now.
Seems way nicer. And I mean, I don't know that for sure, but I'm guessing.
It's very sunny actually.
So we got some people from UK, Paris, France, Vancouver, Austin, Texas. All right, we'll start in about 30 seconds. And yes, Abby, we today's the first day we have elevator music, upping the production quality. And with that, the song just ended, so maybe that's the sign. That's the sign that we're gonna get it kicked off. All right. So let's see here. All right, I'm gonna go ahead and share my screen, and we are going to kick this thing off. Thank you everyone for joining. Today it's a really going to be a really fun one because we have a number of people that are gonna kind of show some demos and talk. So we have you, John, Daniel, and James, and I'll introduce everybody here as we go through. I'm sure there'll be more people coming in, but definitely ask questions along the way. We'll try to answer them. If we don't get to them all, we will have time at the end. And we will also be sending out the recording. So if you did have to leave early for some reason, it'll be a few hours after the event, but we will send it out, and you should just get it in your email or whatever you used when you signed up for the event. All right. And with that, let's go ahead and get started. So I'll go ahead and share my screen. So we'll start with kind of just going through a few slides, talking a little bit about what voice agents are, and then we'll spend most of the time in actual demos, because that's the fun part. People want to see how it actually works. But let's start with what the goal is of this workshop. We want to basically build, monitor, and test voice agents. And so we want to learn some of the tools and tricks for actually doing that. And we're going to cover what voice agents are, what are some of the use cases people are using voice agents for today, learn a little bit more of how you can use voice within Mastra, and then how you can actually monitor and test those voice agents with Rourke. And then I have some time for a Q&A. So about me, a little bit about me. I'm a co-founder of Mastra, the chief product officer. I was formerly at Gatsby and Netlify. I built a product called AudioFeed, and I've been in open source software for quite a few years now, but not to date myself too much, hopefully. Ujon was previously at Netlify, and he's kind of our voice and one of our cloud experts on the Mastra team. So you definitely reach out and connect with him. And these slides will be shared as well after the event, so you'll get this in that follow-up email. And excited to also introduce some friends of ours from Rourke. So James, he was previously at AngelList. He's been spending the last 10 plus years, last decade of his life in web and cloud development. And he's the CEO of Rourke. And Daniel is the other co-founder of Rourke and CTO. And he's previously at a YC startup, and also, kind of been doing this for a decade. We're getting old. All right, so let's talk a little bit about voice agents and why now they're becoming more and more popular. They've been around for a little while, but a lot of things have started to come together that really make it a really good time to start to build voice agents. They're starting to have this, shift from just a text chatbot to more natural voice. People want to get their questions answered quickly and directly, and typing something out on their phone through a little keyboard is sometimes not the best way to actually do that. And also with the model latency going down, the costs going down, some of this stuff starts to become more feasible, where before, especially because voice is so latency sensitive, before it was really hard to do. It's becoming a lot easier now. So talking a little bit about what makes up a voice agent, the more traditional typical flow is you have some kind of speech to text provider that takes audio, turns it to text. You have some kind of LLM that does the reasoning and actually generates a response. And then you have a text to speech provider, which, then kind of speaks the response back to you. So you kind of have this pipeline. The nice thing about this is you kind of have three different pieces. It's pretty modular, but each step in the process does increase the latency a little bit. That's why it's really important that LLMs are as latency sensitive as possible, that you can do the transcription really quickly, you can do the text to speech really quickly, because any additional latency in voice starts to kind of break down on the experience. There's also something that's a little bit more new, is kind of real-time voice-to-voice models. So essentially, it's all just one API or one model that does all three of those steps in one. And so because of that, they can reduce the latency on, the handoff between those steps. And so OpenAI real-time, it kind of streams and transcribes words as they're produced. So it's actually creating the tokens and then streaming the tokens as they're actually produced. So you don't have to wait for the whole response to happen before you can start streaming it in. So you can really reduce latency. But because it's kind of a, one black box, so to speak, it is harder to debug still. It's because it is newer. It's a little less flexible, so you don't have quite as much control. So we kind of see that there's really like three common architectures that we've been seeing with customers that we've talked to, that I've spent a lot of time talking with Rourke, and they've told me some of these same things. So I've picked up a lot of this from them as well, that you kind of have the traditional pattern of speech to text to LLM to text to speech. That's definitely more mature because it's the more common way. You do have a little extra latency, so that is kind of one of the big drawbacks there. Then you have the voice to voice, which is the lower latency option, and the ability to kind of show more emotion in the speech, but it's still earlier stages and it's a little less flexible right now. And then you have some of those full stack platforms, which are battery included. I always like to equate these to like the no code website builders. Like they're pretty good and you can get really far with them, but oftentimes you get kind of locked in and you have limited customization. So there's definitely some trade-offs there. As far as some industries that are using real-time, or I guess I should probably just say what are use cases on this slide, but we've been seeing a lot of use cases in customer support, financial services, insurance, healthcare, and then, kind of training and coaching. So a lot of like back office, a lot of customer success, customer service, kind of types of use cases that we've seen quite a bit as we've been talking to customers that are using Mastra. And so there are, maybe, I don't know if anyone here has experienced it yet today. You can still sometimes tell when you're not talking to a real human, but a lot of times it only handles part of the customer service, right? You can still get to the human. A lot. I think that's most people have success when they can take out like certain tiers of support, kind of the easier parts, and then they still often end up going to kind of that actual human in the loop to respond to the more complicated requests. I would have some kind of general learnings that we've had as we've talked to customers building voice it's best to start simple, pick a more narrow use case with, kind of a clear return on investment, clear like understanding of what kind of latency is acceptable. And then the other thing I would suggest is continue to revisit the architecture as these real-time models get better. I really do think that more and more of this is going to end up as those real-time models being the best solution. It's not quite there yet for all use cases, but it's probably something worth evaluating every quarter or every 6 months after you kind of build out your voice agents. And then, I would also encourage you to build evaluation and monitoring in the pipeline from the beginning. So you can really make sure that as you scale, you have the right pieces in place to know that your voice agents aren't going off the rails, right? They're making the right decisions and they're actually solving problems for you. And before we jump into the demos, I'm going to do a quick introduction to what Mastra is, and we'll talk a little bit about Rourke as well. So I'll toss it over to James here in a second. But Mastra, if you're not familiar, we're an open source AI agent framework for TypeScript. We have a whole bunch of things kind of out of the box. You have agents with tools, memory, tracing, and voice capabilities. We have agentic workflows, which are more deterministic with simple APIs and human in the loop. We have evals framework built in. We have RAG built in. We have a local development playground, which makes using it all very easy. The goals around Mastra are to be opinionated but flexible, meaning we have sensible defaults so you can get further faster, but we don't lock you in so you can kind of swap anything out that you need and make sure it really can grow with you. And I'll hand it over to you, James, to talk a little bit about Rourke.
Thanks, Shane. Yeah, so you can think of Work as a Datadog for voice AI. So the idea is that we help voice AI developers like yourselves figure out if their agent is going to go off the rails or not. And we do this by providing tooling that allows you to monitor and evaluate the performance of your agent, both in production and while you're testing. We allow you to run simulations against your latest voice AI changes and check for regressions before you deploy a change, whether it's to the prompts, whether it's to tool calling, whether it's testing out a different speech to text model. Before you deploy your changes, you can use Work to tell you whether that's going to cause any regressions or not. And then we also have some really powerful analytics and reporting built baked in that allows you to analyze the behavior of your agent across all of the aggregate data that we collect across all of your calls. Yeah,
Awesome.
with that, I'll hand it back off to Shane.
Yeah, and with that, let's actually just jump into the demos. That's what everyone's here for anyways. And so I'm going to hand it over to you, John, we're going to start by first showing how you can build voice agents in Mastra, and then we'll also then show how you can analyze and monitor those using Rourke. So yeah, give me 1 second. I will stop sharing and I will allow you to take over, you John.
All right, thank you, Shane. So yeah, before we begin, I'll talk a little bit about what Masha provides in these demos. So as Shane mentioned, voice agents are becoming more popular. And here at Masha, instead of creating a new or a different framework for voice agents, we want to give the ability to give voice to your agents instead. And we do this through a unified API, providing text to speech, speech to text, as well as speech to speech. So in this, I believe I'm sharing my screen here, and we have our voice workshop demo, which will be repo, which will be available after this workshop. And the first thing we'll take a look is the API itself. So here we have three different providers, all implementing the speak method, which is a method for text to speech. And we have so what we do is we import our an instance of our Masha voice provider which is from our Masha voice degram here. We also have one for OpenAI and one for the real-time API. So how would you use this on an agent? We'll go take a look here. There's a couple different ways. So if for a single provider that offers both speech to text and text to speech, what you can do is the agent has a voice property where you can assign the OpenAI you can assign an instance of the Masha voice provider. So in this case, we're using OpenAI. Now, if you want to use a different provider for speech to text and one for text to speech, what you can do is you can use composite voice, which is imported from our Masha voice core pack, our Masha core voice package. And here we are assigning dgram as our input for our speech to text. And here we are assigning our OpenAI as our text to speech here at the output property. Now, when it comes to real-time API or like real-time models that offer speech-to-speech capabilities, it's very similar to what we've seen before with a single provider. And here's an example with OpenAI real-time voice. So with that being said, I'm going to go over the different building blocks of creating these agents, starting off with speech to text. So here we can, it's a very simple example where we are importing our OpenAI voice, and we are taking an audio file and creating a stream from that, and we are passing it to our listen method on our voice instance. So here at Mastra, we want to personify our agents, which is why we stuck with the methods listen for speech to text and speak for text to speech. So once we transcribe this audio file, we're just going to log it out. And yeah, let's see how it goes. So this audio file, actually, I should have played this before.
Grocery bags, especially the reusable ones.
That was just a test to see if everyone can hear the audio as well. So it was a debate about grocery bags and how they provide. It was a debate created by two agents. Actually, we'll look into this demo later. But what we did now is just see that okay, we have our transcription here. So the next part is how do we use this with an agent? And so here in our second example, what we're going to do is we're going to take the audio from my mic, and then we're going to pass this into our agent listen method to transcribe it. Then we're going to pass this into our generate function and see what the agent responds with, and we're going to log that out. Why is the sky blue? So apparently the sky is blue because the molecules in the Earth's atmosphere scatter sunlight. And as you can read the rest, that's why the sky is blue. So this is just a very short demonstration of how speech to text works with Mastra. The next lesson we'll go into is text to speech. So here it's very similar, except now we are using the speak method, and we're passing a string on what we want the speech synthesis to happen, or we're creating an audio stream, and we're going to play it to our speaker here.
Hello, how are you doing today?
All right. So now when it comes to the agent itself, we're going, in this second example, we have our agent who's going to generate, there's a capability of looking up things online. So he's going to search up for the latest news about the Lakers and just talk about the headlines, the top 3 headlines there. And then once that we get that text, we're going to pass that in to our speak method, where we specify, a response, and where we specify the audio file, which is wave here, and we're also going to just bump up the speed, just for this demo here.
One, Luka Doncic's 39 points lead Lakers to clinch 3rd seed in Western Conference. 2, Trailblazers dominate Lakers 109-81 in regular season finale. 3, Mavericks GM defends Luka Doncic trade to Lakers, expresses no regrets.
All right. Well, we heard it. Mavericks GM has no regrets trading Luka Doncic. So what Shane mentioned before about the different providers, we have one for speech to text, we have one to generate a response, and we have one for transforming text to speech. And this is just these two examples for pretty much showcasing that. Now, before I hop into the our voice-to-voice into our voice-to-voice example using a real-time model, we do have one more example of text-to-speech. And this one is simulating 2 agents having a debate about a topic that I will provide. So if we scroll down, we fetch our 2 agents from the Amash instance. We have our optimistic agent, and then we have our skeptic agent. And then we pass these into this method called process turn. And here is just what we're saying is, okay, so based on the previous response, the previous agent's response, come up with your own, respond to their talking points here. And here I want to introduce a new package called Node Audio Package, and our @Mastra Node Audio Package. And we created this package because when we were creating these demos and for this workshop, we found it very cumbersome just to get started. Just if you want to if you want to play audio or record your mic or even record the audio to a file. So we created this Mastra Node Audio Package to simplify that process. So I highly recommend to check it out. We're going to continue iterating this as we create more workshops and more of these demos. So it's a fun package just to get started. So for this topic, we're going to talk about Seattle because I'm living here right now.
Seattle is a vibrant city brimming with innovation and natural beauty. Known as the Emerald City, it offers a unique blend of urban excitement and lush green landscapes, making it a haven for both tech enthusiasts and nature lovers. With iconic landmarks like the Space Needle and a thriving art scene, Seattle is a hub of creativity and opportunity.
Sure, Seattle's got its attractions, but let's not ignore the notorious traffic and skyrocketing cost of living that plague the city. It's hard to enjoy all that vibrant innovation when you're sitting in congestion or struggling to pay exorbitant rents. And as for being a hub of creativity, doesn't every major city claim that these days?
Well, I say they both have pretty valid points. It is pretty green and vibrant here, but cost of living is quite high. So now we're going to dig into the voice-to-voice, our voice-to-voice, how to implement voice-to-voice agents, and using real-time models. So one of the main differences between this example and the past 2 other examples is that now these real-time models require different methods as well as handling We also use an event-driven architecture as well as, a different kind of connection or protocol to send information. In this case, we're using WebSockets. This is all to reduce latency for our responses here. So I'm going to give a high-level overview of like what the methods are for when it comes to implementing these voice-to-voice capabilities on these agents. So first we have our get microphone, or sorry, this is coming from the Node audio package. So first we start with connect. This this sets up the WebSocket connection. And we also have close, which disconnects the WebSocket connection. And with these voice real-time providers, you can give them tools. So one way to add tools to these models is through the method add tools. Now, if you create your agent with tools already attached, like I'll show here an example, these tools here are already passed to that model. So you really need to use that method at all. We also have a way to update the instructions or the system prompt. Agents or agent voice speak. So before this would return a readable string, but now it will emit a speaker event. So the speaker event is when the agent's responding. We also have a method called voice.send, and this is where we send my response or audio to the agent. And then we also have a listen event or listen method, which will emit a writing event. So this is for transcribing audio. So in our writing event that's emitted, we have two roles, the assistant and user, and then we can also log out the text or we can also log out what was being said. Here we have a way to update the config. So the config in this case is the session config. You could think of a session as the entire conversation between myself and the voice agent. So in this example here, we are going to we're going to change the configuration on our voice activity detection. And what this will do, this will emit a session updated event, which you can add handlers on. And if you're not using voice audio detection, and as we stream my response to the agent, we're going to need a way to trigger a response from the agent itself. And that's where the answer method comes in. And this will then emit a response created event and followed by a response done event. We also have an event to listen when the agent invokes a tool. So this is the tool start event, and then we also have one for after the tool has been called, and after the execution has been called, this will emit a tool call result event. And then finally we have error for error handling. So now we can go into our example here. So this example is a voice agent where we are going to record my audio and we're going to upload it to Cloudinary and then send that to Work. So here we have we initialize our Work client with their SDK. The create conversation is pretty much the method that has all the logic when it comes to these interactions. But before I dive into that, I want to take a look at specifically this method on conversation ends, which will be called when the conversation ends. And this is where we take our audio file and we're going to upload it to Cloudinary, and we're going to get our URL, and then we're going to pass this into the Work SDK. Here where we also pass in when the conversation took place. Here we're simulating an inbound phone call. And then we also have passing the participants. Here we have the agent, and we're specifying that the agent spoke first. And then we also have myself as the customer. We can also pass in tool invocations. So this is like, we're going to pass in a list of tools of when they were called and what they were called with. And then we're just going to log this response. So when we go into create conversation, I was just going to highlight the main thing since we're running low on time here. We're first going to get our agent from the master instance. Then we're going to listen for the speaker event. So remember, that's when the agent speaks, or when the agent sends a response, and we're going to play that, send that stream, and we're going to play that audio. Next, we're going to then listen for when the tool call starts. This will allow us to know, this will allow us to give the information to work of when a tool has been called. And then once it has been called and it's been resolved, we're going to take that tool notification, we're going to take when it was started, and then we're going to pass it into an array that we will send to work. And huddle, this is another method that's being created, that is being imported from our Node audio package. And this will handles the microphone, the speaker, as well as the recording for us. And finally, when we want to start the conversation, what happens is we first start our WebSocket connection. Then we start our huddle, which is, again, the audio and the recording. And then we're going to send my audio, we're going to send my audio data to the send method. This is for me to send a response to the agent. And then if there's an initial message, the voice agent is going to emit a speaking event. And yeah, I think that's about it. So we're going to get started and see how this demo goes.
Howdy, partner.
Hey, what's the weather like in Seattle?
It's clear in Seattle right now, with a temperature of about 10.7 degrees Celsius, feeling like 8.3 degrees Celsius, and a moderate breeze.
Okay, cool.
Glad you think so.
So once I stop that conversation, we're going to go back to here and go and take a look at these logs. So here we can say the log send to work URL. So this is our audio file here, or the URL to our audio file here. And then this is the response that we're getting from work. We can see that the status is pending. And we are sending, we have our information about myself as well as the agent, when the time was called, as well as what kind of call this was. So just to wrap this up, this is a way of how you can create voice agents with Masha. So I'm going to hand this off to Work, who can now explain how we can use this conversation audio as well as the other additional data to monitor and evaluate our agents.
Thank you, John. So we can get started by actually going over our integration docs, just to give you a little bit of more context on how we would integrate a voice agent with Rock. So let me share my screen. Yeah. So as you can see here, we basically have an SDK for both Node and for Python. Obviously here with Master, we're using the Node.js SDK. If you're working with another language, you can also hit our REST API, and that will allow you to send the call over to Rook. When it comes to data that we need, as Eugen already showed us, it's very simple. From our end, we mainly need an audio recording. From that, we'll basically do everything else. We'll handle the transcription, we'll handle sentiment detection, every other thing that you will need to do, we take care of that. When it comes to the properties that you need to pass us, other than the recording URL that you can see here, you can also pass in any additional properties that you might need. These come in very handy if you want to filter some calls. Let's say you have some calls that are bound to a particular agent or to a particular customer, for example. You can use these properties to filter both in the calls list, which we'll show you later, as well as in the reports. Besides that, you can also pass in tool invocations. So tool invocations will allow you to evaluate any tool calls that you make across your agent. Tool calls tend to be a little bit tricky. It's one area where the LLM tends to hallucinate, especially when it comes to calling the tool or calling it with incorrect parameters.
So passing that over to us will basically allow you to easily evaluate if they're being called correctly or not. Finally, the participants is one of the required fields. The main thing that we need to know is who spoke first. Yeah, when you basically just need to pass us the agent and the customer details and tell us who spoke first. Based on that, we'll be able to transcribe and diarize the entire conversation. So what does this look like? Once you actually post the call, you'll actually start seeing this on our dashboard. And there you'll basically see the transcription and all the details that we get from that. This is a very quick example, so I'll hand it over to James, who can show you a better example of what this would look like in production.
Thanks, Daniel. Thanks, you, John. Okay, cool. So let me go ahead and share my screen here. Cool. So yeah, so for this demo, what we're gonna highlight here is, let's say that we're building a voice agent and we're building one for a dental clinic. And the goal for us is to be able to schedule appointments for customers, along with answering some of the common requests. So what Daniel and Yujon just showed you is the way that you would build that agent using Mustra, and then how you would send those calls over to Rourke. So for every single call that comes in, you'll be able to see them over here on the left-hand side. And then once you tap on a single call, we'll automatically handle the transcription, we'll handle everything in between, from transcription to sentiment detection, highlighting the tool, invocations, we'll run evaluation. We also are able to capture some very rich emotional and vocal cue information. And so the call that you're seeing in front of you is an actual call between a customer of this dental clinic and the voice agent that's running. And so just to help gain some context here, let me go ahead and play back the audio. I just realized I shared without sharing sound, so let me just reshare my screen real quick. Cool. Okay.
Hello, this is Mary from Mary's Dental. How can I assist you today?
Hi, I'd like to book an appointment for a root canal treatment, please, preferably on Tuesday at 3 p.m. if that's available.
I'm sorry, but we don't offer root canal treatments here at Mary's Dental. However, I can help you with a cavity filling if that's related to your issue. Would you like to book that instead?
So what we heard here is a pretty strange call, right? Essentially, the customer calls in, they want to book a root canal treatment. We know that every dental clinic on the planet supports root canal treatments, and so does this one. But unfortunately, the agent screws up. It starts to hallucinate. And the reason for this is because the way that this works is you would define the treatment types either in the prompt or in your knowledge base. And in this case, the developer just simply forgot to do so. And so the agent just doesn't know what to reply with. So it starts to hallucinate or offer alternatives, which in this context is strange. So what we do as Rourke is, for every single call that comes in, we will run a set of evaluators across those calls. These evaluators can be defined by yourselves in the evaluators tab. You can go in, add in some of the testing criteria. For this demo, we just have one running right now, which is called answer relevance, which is essentially going to test whether the response the agent gave is relevant to the customer's request. And what we can see here is we highlight these failures from the evaluation results in two ways. We do so in the transcript, so we'll tell you, hey, there was an irrelevant service offered, right? That the agent offered the cavity filling, but it didn't really directly answer the customer's request. We'll also highlight these failures directly in the waveform. So if this were a 20 or a 30-minute call, depending on the use case, you wouldn't need to listen to the entire thing. You could really quickly just scrub to the pieces that you care about mostly. And then you can also see a summary of the evaluator just by tapping on it. And then we'll show you the score, the reasoning behind it, and then an entire breakdown of the relevant segments within the transcript that led to this evaluation result. On top of that, we also capture that rich sentiment information, emotions, and vocal cues. And what this means is we'll be able to capture whether the user raised their voice or whether they were interrupted. And then we use all of that audio information along with the function calls, the transcript, to evaluate whether your agent did what it was supposed to set out to do. Cool. So that is the core foundation of our product. Now, on top of this functionality, we've built two other features. One which is reporting, and then another which is simulated replays. So let's get into reporting next. So let's say that we've now this is live, you're in production, you're now making like hundreds or thousands of calls per week. And this screen in particular is great if you know the exact call that you want to go to. But that is usually the issue, right? In most cases, you want to see a high-level view of how your agent is performing. And so what we built here is this concept of dashboards and reporting, where you can go in, you can create your own reports, attach them to dashboards. This is some sample data that we put together here for this use case. But essentially, you can see things like here are the total number of successful calls, what the average emotional sentiment was over the past couple of against this time period. You can see the top reasons for call failures. And then one of my personal favorites is this call topic flow, which shows you a high level of the most common paths that your agent has taken. But let's show you how easy it is to create one of these reports yourself. So let's jump into the reports tab, hit new report here. What you're going to do is, let's say that we're going to select the past 7 days, and we're interested in seeing all of the calls where the evaluation has failed, right? And so now we see we have 7. Okay, let's go over the past 30 days. Great. This is interesting, but it's still not super useful. What you can do from here is you can actually hit on the breakdown button here and break this down by evaluator name. And then now we'll see that we have, essentially, if you have multiple evaluators, you'll actually be able to see which evaluator has failed. And then you can also see the matching calls for that specific evaluator. But what's cool here is you can actually keep adding more and more metrics. So let's say we're going to add, let's see all the emotions that were detected. And we say, okay, we have 480 emotions. But now let's break that down by the emotion. And so we can see that we have 300 emotions of sadness that were detected over the past 30 days. You can even tap into these and see all of those exact relevant calls. And then you can either group by the total number of events, or you can group by the total number of unique calls. Cool. So yeah, so that's reports. So the final thing I'd love to show you is the concept of a simulated test set. So I'm just going to jump back into the failing call that we saw earlier on. And just go here. Cool. So let's just. Okay, great. So let's say that we want to fix this issue, right? What a developer would do today is they would go into their prompt, they would update it or add to the knowledge base. They add a new treatment type, and then they would literally grab their phone, call their agent, and try to mimic the customer in this conversation. And so what we built is this idea where you can simulate a replay of an existing call, where with the tap of a button, you select the evaluator you want to test for, the agent you want to test against, and then you just hit start test run. And what's going to happen here is Rourke is going to call your agent. It's going to literally go through the phone lines, call your agent. It's going to act as the customer and have a full end-to-end conversation. And it's going to be mimicking that customer that we saw in that specific call. And the cool thing about this is not that you can simulate one call, but it's that you can simulate hundreds or thousands of calls in parallel at the same time. And so this is a great way, this is great to add to your CI/CD pipeline so that, anytime you say you're going to update your prompt, you can have a test case that you run before you deploy that prompt to production, right? Or you add a new tool call or you change something in your agent. And so this will take the same duration as the actual call. So let's just jump to the result here. So once the test cases have completed, you'll actually get a very simple pass or fail. You can even tap into it and you'll be able to see how the simulated conversation went. So in this case, you'll see that Rourke acted as the customer. It also put a root canal treatment. But now the agent no longer got confused. It actually went ahead and asked for your full name. This is assuming that we went into our prompt and we've now modified it and we just tested it again. And so, yeah, we just went from essentially from a failing test to a passing one. And yeah, that's simulations. Cool. With that, I'll pass it back over to Shane.
All right. Yeah, a few slides here just to wrap up, and then we will have time for questions. We've been answering a lot of them as we're going. So if you do have questions, get them queued up, and I will just share my screen here once I find what screen to share. All right, there it is. All right. So just to kind of wrap up, so some quick links if you are interested in learning more about Mastra, you have that listed there, and some links for Rourke. You know, you can find their GitHub repo, their website. You can connect with them as well. And if you know, one thing, if you want to do a little bit of audience participation, if you haven't already given Mastra a star on GitHub, please go do so, and you can join the Mastra Cloud Beta if you're interested in actually being able to deploy Mastra agents or Mastra workflows to our cloud service. And I guess, James, you want to talk through this?
Yeah, so for everyone that joined this workshop, we're giving 3 months of unlimited usage for anyone that signs up to work. Just on our startup plan, to be clear, but you could just simply go to work.ai /master-workshop and just fill in the details, and we'll reach out to you. Yeah.
Cool. So for anyone wanting to build or monitor voice agents, that's a cool promotion. And if you want to get started with Mastra, just npm create Mastra and you can get started. But let's go ahead and open up everything for questions. So the last one on the list, is there a Mastra ambassador program? I can talk through this one, not officially, but reach out to me and we can talk about it. We definitely are, happy to encourage people to go talk at various events, various meetups, things like that. So definitely reach out. Let's see. Do you have an idea of when the Mastra client SDK will be able to stream to Mastra? Are you talking, Brandon, in terms of voice or just streaming to like the front end with text voice?
All right, I can take this one.
Okay, yeah,
I
go
can take this one.
go ahead, Abby.
Yeah, so we actually have a PR right now that takes the. Okay, let me take a step back. With OpenAI real-time, as well as any real-time model, you can connect via WebSockets or WebRTC. That's what the connection method does. When you're doing WebRTC, you want to do it from a client, maybe a browser. So we have a PR right now that we've been working on that allows the Mastra client SDK to create a WebRTC connection and then essentially talk to the real-time model. And it's really fast and really nice. So that is coming. We couldn't get it working for the workshop, so that's why it's not here. And I just want to make another point about voice in general. So thanks for everyone for coming to this workshop. As you can see, like Mastra is not a voice framework. We are an agent framework. But voice is such an important part of our community and the AI industry, or at least it's going to be. And so our kind of mentality is we want to bring agents that can do voice, right? Not a voice framework, right? It's a different type of way of thinking. Everything we show today is like our steps of building these Lego blocks, right? That eventually will come together into something that you could put in front of a phone or a call center or everything. So we are like, this is our first voice workshop. The next one will be even more developed, right? Imagine what we showed today was like Legos, and the next one will be like the Millennium Falcon or something, right? So just wanted to mention that.
Yeah, and to continue on that, Max has good questions. Integration with WebRTC, integration, with something like Twilio, voice activity detection. Yes, exactly right, Max. Abby kind of already answered that, but those are things that are coming. They're not necessarily fully baked today. You could, of course, roll a lot of this stuff yourself, right? You could build on the Legos that we have, but we want to make it even easier. So there'll be more to come in the near future. All right, let's see. Do we miss any other questions? We had some good ones that we answered along the way. Pipecat is a bit hard for now. Yeah, I guess James or Daniel, I know some of your customers are using Pipecat, right?
Yeah. Pipecat's a great framework for Python. I think anyone building in Python is defaulting to Pipecat today. And so, we really want to see Mastra become the Pipecat for TypeScript in the voice AI land. Yeah.
Yeah. Yeah, a lot of what we've looked at PipeCat quite a bit too, just as we're evaluating how do we best build the right voice tools for our agents. And so but yes, it is. I think voice is still early enough that there is, once you get outside of kind of like the some of the big platforms, it gets more complicated. There's a lot of moving parts with voice, right? You have the streaming both ways. You have, a lot of different components, and each one of those adds latency, and it's a very latency sensitive, thing with having a conversation. So it is very early. All right. Do we have any other questions? Otherwise, we can get out of here, give 10 minutes back to everybody. But I'll hold for another, 60 seconds in case anyone else has other questions. And just to reiterate, the slide or the repo that we showed today will be available. It'll come out in an email. Usually it'll take me a few hours to get it out. So, but it'll come out sometime today. You will have the access to the video recording, the slides, the actual code itself. And, we'll send you a link to any of the stuff that we kind of shared on here as well. All
Hey
right.
Shane, sorry, it's Frank. Sorry, just wanted to ask
Yeah.
just a real quick one. It's
Yeah.
a little bit of a follow-up to kind of like, would it be possible to create like a Fireflies like meeting note taker? I have been talking to the folks like from like Arcade and stuff like on the authentication side and authorization side. It's just like it's not super clear how like that kind of thing would happen with like an agent that's like watching like my calendar or something like that. Like just briefly, like obviously like we only have a couple minutes, but how do like agents like monitor and like watch processes or things that are coming in?
Yeah, so there's a lot of things that I think we can unpack there. So a couple things, right? A lot of this stuff, depending on how it's built, could be webhook driven, meaning that an agent gets triggered at the end of a call. So if let's say you just wanted to build a call recording for Zoom, well, I'm pretty sure Zoom has the ability to basically subscribe to at the end of when a call recording is available, you could pass that recording URL to an agent that would then process that. So that's one option. You'll see even in this meeting, I think Abhi has his note taker. So Fireflies, for instance, they actually do it a little bit differently. They're essentially joining the call and then recording it as as the call is going on. So they're getting a separate recording than what you would just get with like a Zoom cloud recording. So that becomes a little bit more complicated to actually pull off. There are some different tool providers that are starting to provide better like authentication systems for, MCP, for instance, where you could then connect to different services and your users of your app could maybe pass their, OAuth credentials in and you could use those. But it is still a very early space. So I think the only one I've really seen so far that kind of works is Composio. They have some MCP authentication that would allow you to do that, but most of even using MCP today, which is the easiest way to get connected to tools, is really more for personal use cases. You could probably really easily build not easily, but you could more easily build a personal voice recorder. Once you wanted to build an app that allowed your users to, connect their voice recorder, that's where the authentication still is very early and it's not really figured out yet. People have obviously figured it out, but it's very much you have to implement a lot of the features yourself. I do
Got it.
anticipate over the next couple months it's going to get a lot easier though.
Awesome, man. Thanks for the info. I'm trying to like sign up for like the cloud hosted solution, and I just had some follow up questions. So, is there anyone I can like reach out to or kind of like schedule something?
The Mastra Cloud?
Yeah, yeah.
Yeah, reach out to me. My name
Okay,
at Mastra.ai. I'll get you set
okay.
up.
Sounds good. Thank you.
All right. Any other last minute questions?
I
All
just
right.
asked you for the record of last workshop. You have it, just to have a reference for the sheet
Yep.
you shared to me. Thank you.
Yep. Give me 1 second. I'll drop it in the channel. So anyone who wants access to it, we could just make them public. We send it out to anyone that signs up, but I will just get you the link here. So it's just unlisted. There you go.
Awesome. Thank you very much.
All right, everybody. Well, thanks, James. Thanks, Daniel. Thanks, you, John. Thanks, everyone, for attending. And yeah, hopefully we'll see you at some future events and continue learning more about AI, agents, workflows, voice, all those kind of things. Catch you later.
Yeah, thanks for having us. See you.
Awesome. Have a good one.